Greetings to every one of you. In this video, we are going to discuss about another very important concept from design and analysis of algorithm, that is asymptotic notations. Asymptotic analysis is used to measure the efficiency of the algorithms. So the efficiency of any algorithm, it depends upon two important factors. So one is time and another is the space. So the asymptotic notation, it used to analyze the time as well as the space. So we need to analyze the time complexity and the space complexity. The time represent the amount of time taken by the algorithm for the execution. So it refers the processor time. Similarly, the space complexity, it refers the amount of memory is going to be used by the algorithm. So these two things are very essential in order to perform analysis over this algorithm. So what is required in order to get the efficient algorithm? We need less amount of time and less amount of memory. So the algorithm, we can say that the algorithm is efficient only if which consume less amount of time and less amount of memory, then we can say the algorithm is efficient. So these asymptotic notations are abstract notation for describing the behavior of algorithm and determine the rate of growth of a function with respect to the time and arbitrary large inputs. The time complexity values are given in increasing order as follows. So any that is a time complexity, the minimum value it is 1, less than log n, less than root n, less than n, n log n, n square, n cube, 2 power n, 3 power n, etc. up to that is n power n. So this is the order of this time complexity. There are three types of notations available as far this asymptotic notations concerned. Number one is called big O notation. Number two, it is a big omega notation. Number three is big theta notation. Let us see one by one. So this big O notation, it represents the upper bound of an algorithm's running time in the worst case scenario. As for the big omega notation concerned, it represents the lower bound of an algorithm's running time in the best case scenario. Similarly, big theta notation, it represents both this upper and lower bounds of an algorithm's running time, which is the average bound or average scenario. Let us start from the big O notation. The big O notation can be defined as f of n is equal to big O of g of n, where g of n is a differential function if and if only if there exist positive constants c and n naught, such that the f of n lesser than or equal to c into g of n for every value of n greater than n naught, and this n naught must be greater than or equal to 1. So here the n represent the number of steps involved in the algorithm, or I can say the size of the input. See, we have a connection between these two. See, for example, if you have writing a statement, simple assignment statement, it can be considered as one step. But for example, if you write a loop, the loop contains number of steps. It depends upon the final value of the loop. For example, for I is equal to 1 to n, and you are accepting the value for n. So some statement you are executing inside that loop. So that statement will be executed for n number of times. Okay, though it is a single statement, but the statement is present inside the loop. It depends upon the size of the input, that is n. Okay, if n value is 10, it will be executed for 10 times. If n value is equal to 100, it will be executed for 100 times. So that is the thing you have to remember. So this the n represents number of steps, or you can say that it's the size of the input. So the function here, we are saying that n must be greater than n naught, and n naught must be that is greater than 1, greater than or equal to 1. Okay, so that is a minimum value. So at least if we say it is an algorithm, minimum there should be one statement. That is a meaning. Okay. So let us consider we have a function. So this f of n is equal to 2n plus 3. You will substitute this value in this equation. So it is 2n plus 3 lesser than or equal to c into g of n. Okay, so this g of n, assume it is n, right? Let us consider if n is equal to 1, so what will happen? So here this is 5 lesser than or equal to, and this is 1, and if you substitute a value 1 for this constant c, we got the value 5 is less than or equal to 2. Okay, so the condition is not satisfied, condition is false. So what you have to do, you have to, that is get the minimum value for satisfying this condition. So what is the minimum value when this condition will become true for the first minimum value? What is that? So one thing, if I keep the value of this constant as 5, the value of c as 5, so the condition is true, 5 is less than or equal to 5. So that is the minimum value. In otherwise, what you can do, you can get the minimum value for c and you can increase. For example, if I reduce the value of c and I have to increase the value of n. So now the condition, it is 2 into 2 plus 3, it is 7. 7 is lesser than or equal to, that is 8. So the condition is true. So minimum value, that is it is nothing but the n. So any value that is greater than n, that will satisfy the condition. So if you look at this time complexity, what I have written in this increasing order, okay, so the value, anything that is equal to n and greater than n, that will satisfy this condition. So all these values, satisfy this condition. Right from n, then n log n, n square, n cube, or 2 power n, or 3 power n, or up to n power n. So this condition satisfies. Okay. So but we have to consider that minimum bound, the minimum value, that is nothing but n. So this can be written as big O of n. This is the complexity for this upper bound. Okay, this is the complexity for this upper bound. So big O of n. Let us consider in the graph. So this is our the function. This is our function, that is f of n, and we have this upper bound function. let us consider it is the upper bound function, that is g of n. So in this case it is c into g of n. So here this value represent this n0, n0. Okay. So any value that is present, that is this area, this represent the upper bound. This is the upper bound. So this is nothing but the big O, the big O representation. Right? Is it clear? So next we move on to the big omega notation. The function f of n, it is equal to omega of g of n if and only if there exists positive constants c and n naught such that f of n greater than or equal to c into g of n. So here it was lesser than, but here this f of n is greater than this differential function g of n. Okay. So for every value of n greater than n0, and this n0 must be greater than or equal to 1. That is the condition. Okay. So let us consider this function f of n is equal to 2n plus 3. So in this case, what is the minimum value which satisfy this condition? So it is 2n plus 3 greater than or equal to the value of c is equal to 1 and g is equal to, that is g of n, that is it is equal to n. So if n value is equal to 1, it is 1 into 1. So what is the condition? It is 5. 5 is greater than or equal to this 1. This is the minimum value. This is the minimum value, minimum condition. So it is nothing but what's that? The value of 1. So this can be written as big omega of n. So any value that is equal to n and lesser than n, that will give you the value of this lower bound. This is nothing but the lower bound. Okay. So if you take this the time complexity, the order here n, and any value that is lesser than n, okay, maybe there is root n or log n or 1, that is nothing but the omega, big omega. So big omega represents the lower bound. See, for example, let us consider we have the curve like this. It is c into g of n for the lower bound. So any area, this this is nothing but the lower bound. All this area, this represent the lower bound. This is upper bound. Okay. So the next one is the big theta notation. So this is the order of thing is big omega of n. It is a big O of n and this is big omega of n. In both the cases you have to remember one thing. So this is a minimum value. Okay, that is a minimum value because we are using the condition less than or equal to, here greater than or equal to. So automatically n it comes here. As for theta notation concerned, the function f of n is equal to theta of g of n if and only if there exists positive constant c1 and c2 and this n0, because c1 it represents the lower bound value and c2 represent the upper bound value. So here this is nothing but c1 and this is c2. Okay. So it is an average bound. So it contains both upper as well as the lower bound. So in that way we have the condition c1 into g of n less than or equal to f of n less than or equal to c2 into g of n. So this is the equality condition in which the value of f of n, it is between the lower bound and the upper bound. So in this case the previous one, what actually the upper bound value, we consider the minimum value is 5. So that is 5 into that is 1. And similarly the lower bound value, it is nothing but that is 1 into 1. So any value that is between these two, the 5 and 1. So that is the the function, that is our function, that is the average bound. So exactly we can say that the big theta of it is nothing but n. Okay, the big theta of n. So you can say that exactly it is nothing but n only, n. So this can be explained with the help of a simple a problem. Let us consider a problem of linear search. We have a set of numbers in an array, and we would like to, that is, test whether that particular value is available in the array or not. Okay, so our value contain the array contain the values like this: 18, 25, 14, 16, 20. So let us consider these are the values that is available in an array. Let us consider we want to search a number, that is a value, it is nothing but 5. The searching number, it is nothing but 5. What will happen? The first seek itself we are able to, that is, get our result. So it is nothing but what is the time complexity for this? It is nothing but 1. It is nothing but big, that is the time complexity, it is nothing but 1. Complexity is 1. So what it means? So if we say that is the lowest value, so that I use this omega representation, omega of 1. Okay, suppose let us consider if it is the value what actually I want to the research, it is it is 20. So what will happen? The value 20, it is available at last. Okay, it is available at last, so it is available at n. So it is nothing but big O of n. So let us consider you have this value that is in between these two. Okay, somewhere I want to, that is extract the value, that is number that is value, that is 13. Okay, so it is in between these these two values. I can say that it is nothing but the theta of it is n by 2. Okay, but normally whenever you are considering the complexity, we have to avoid the constants. So as a result, again this can also be, that is written as theta of n. Okay, so in this video I just explained what is asymptotic notation. So there are 3 types of notations that is available. One is big O notation, and big omega notation, and big theta notation, and just I have shown you how this can be, that is represented in the form of the graph. I hope you understood the concepts. Thank you very much. Keep watching.